Welcome back. In this lesson, we're going to look at the two major types of igneous rock. We're going to look at rock that was extruded or erupted out of a volcano. That's called extrusive rock. Okay, so what once was lava can be extrusive rock. And then rock that never actually made it out of the volcano. So it was melted, magma underneath the ground that could have been lava if it would have simply reached the surface, but since it cooled off back in the ground, it never actually got out of the ground. That's called intrusive rock. So that's the two main type. The difference really is how fast did it cool down. So we'll see in the next lesson that the shapes of these rocks that are made from intrusive or extrusive rocks are completely different based upon the time it took the crystals to restructure. So crystals are now cooling down and coming out of solution and recrystallizing, and the amount of time it takes for those crystals to come out can determine how big they actually happen to be. So what a rock looks like a lot of times, or these type of igneous rocks, has to do with how fast or slowly they cool. So we'll be looking at extrusive or lava rocks, and then intrusive or magma. So let's look at igneous rocks. Igneous comes from the word fire. So this is a melted type of rock. So first of all, you need to know the difference between magma and lava. Magma and lava is made out of the exact same stuff. It's exactly the same. Lava is just the term used whenever magma reaches the surface of the earth and comes out. So it's squirted out of the top of a volcano. That would be lava. Magma is the melted rock that still remains under the volcano, and is possible that it never comes out at all. If it does come out as lava, then magma is basically renamed lava. But if it stays in the ground, then it stays as magma, and then that magma could recool into a rock, and we'll see that oftentimes does happen. So first of all, you have this idea that it's melted, and these melted minerals will then recrystallize whenever it is being cooled. So since all of these minerals have specific shapes, very specific recipes and very specific crystal shapes, as this magma cools, it cools in crystals. Crystals begin to form, and you'll have the crystals inside these rocks where one mineral will be next door to another mineral, and then as they crystallize and then the whole rock cools, these minerals are now components of a bigger rock. Now, just like lava and magma are the same stuff, and lava is squirted out of the ground and magma is not, you have an adjective that follows that. Extrusive means something has been extruded. And extruded simply means squirted out of the top of the volcano. So if you have an extrusive rock, you had what once was magma, then came out of the volcano as lava. So if you have something that once was lava, okay, coming out into the air, not in the ground anymore, but as liquid lava and quickly hardening, cooling, it's called extrusive. So any rock that once upon a time was lava is called an extrusive rock. Now, different volcanoes will erupt differently depending on how thick that the rocks are. So some rocks when they melt, are very thin and runny, and you have a type of lava that's really thin and runny. They don't usually explode. Others that are really thick, as it finally comes out of the volcano, will come out explosively and chunky, and it's basically a thickness, how much silica really is in the lava. If you consider that a lava once was inside a magma chamber, which was a huge liquid rock component underneath the ground, most of that magma will never reach the surface. Even if you have a volcano, most of that is going to stay under the ground as liquid rock. Now, in the cases where the heat source can be removed, let's say that the crust is moving around by tectonic movement, and the hot spot no longer is in the same place. So at one time when the hot spot was there, and you are exposed to the very hot mantle of the earth underneath some rocks, they would melt and you would have magma. If that hot spot moves for some reason, then that magma could recool. It could crystallize again as rock and then recool. It is going to recool under the ground if it's still magma. Okay, so if it does that, then that under the ground rock was once melted, so it's an igneous rock. But since it never came out as extrusion, it never came out as lava, it is called intrusive rock. It's the idea of in and out. X means out, so if it comes out as lava, it's extrusive. In means it remained in the ground as magma and then cooled back to a rock. It's also called plutonic because a pluton is when you have this huge chunk of rock that used to be the inside of a volcano and it cooled under the ground. And this is beautiful rock and often used for carving. Okay, so there's 3 huge plutonic mountains that are used for major carving. One is in the south, or actually 2 is in the Black Hills of South Dakota. You have Crazy Horse, which is a huge monument to an Indian chief. You have the 4 presidents on Mount Rushmore. Those were both plutons. They were both underground magma chambers. And then they take carving very well. Also, the one in Stone Mountain in Georgia was also a pluton, and it has the Confederate generals carved on it. So those are plutonic or intrusive rocks, and they cool under the ground. So magma includes different things. Okay, magma includes some, of course, magma is melted rock, but magma does have some solid parts in it, kind of floating around. You can imagine like semi-melted stuff floating in the soup. You also have some gases, a lot of water. Okay, the water vapor would be, and that's one of the reasons why volcanoes explode, is not because of the rocks are trying to get out, but because the gases are trying to get out and they're basically forming a bomb. Also, ions of these minerals many times. And so these ions are going to configure themselves remember, ionic bonds form crystals, and crystals are these mineral shapes. So many of these are formed by ionic bonds. So as these ions find each other, the positives and negatives find each other and align themselves as they're cooling down, and the electric charges will attract each other, they're going to start forming these very regular crystals. And they start coming out of solution. They start coming out of this liquid magma and start forming solids. So this is the idea of cooling. They cool and they crystallize very orderly. A lot of times, depending upon how slowly that they cool, will determine how big the crystals will be. And so the shapes of these minerals, or the shapes of the minerals inside the rocks, have a lot to do with how long it took them to cool down, whether it was very quick, like a volcanic eruption where it squirts out in the air and basically forms a rock immediately, or it takes an age or 2 for a hot spot to move and that magma to cool down very slowly. You're going to get crystal shapes that are slightly different. Here's an example. Instantaneous cooling results in randomly distributed atom with no crystal growth at all. So for instance, when you have an explosive volcano, a lot of what's coming out of that volcano is actually glass, if you think about it, because glass is silicon and oxygen that doesn't have an orderly structure, doesn't have an orderly crystal. So glass is not actually considered a mineral. So volcanic glass essentially is a silicate, used to be a mineral, that would form a beautiful crystal if left to cool quickly or slowly, but if it comes out quickly, like it's shot out of the top of a volcano, it instantly cools and it comes out as glass. Also, you're going to have lots of gases that come out of a volcano, and those gases could be trapped inside of rocks. And so, for instance, pumice stone is very frothy and has lots of air bubbles in it, and it turns to stone very, very quickly. Doesn't have a lot of crystal structure, but does have lots of air holes. So whatever gases are there can affect the rock. Okay, if there's gases, you can get air bubbles. If not, you can't. And then how quickly or slowly they cool will determine what kind of stone you end up with after that magma cools off. Here's an example of scoria, which is from a volcano, and you can see lots and lots of air pockets in there as it has come off frothy as it's come out of the volcano. It's coming out, it's got gases entrapped in it, and then it's cooling off rather quickly because it didn't have time for the gases to escape, and then basically it forms this kind of cork-like or bread-like rock called scoria.